factor each of the expressions. So this is a trinomial. 2 times -3 is -6. I want to think of two numbers. That multiply to equal -6, but add or subtract to give you a +5. Two numbers that multiply to give you -6, but add or subtract to give you +5. That would be +6 and -1. Combined to give you +5, multiplied to give you -6. So x plus 6 and x minus 1. A common mistake we see is that when the front number, the leading coefficient, is different than 1, you have to do a bottoms here. This reduces to 3. Because this cannot be reduced, we push it up, bottoms up, 2x minus 1. This is the factored form of this expression. Number two. What multiplies to give you 20? What multiplies to give you 20 and combines to give you 12? So what multiplies to give you 20? Positive 20, and combines to give you 12. That'd be 10 and 2. So t plus 10 and t plus 2. Because the leading coefficient is different than a 1, I put a 5 underneath. I reduce when possible. And if it can't be reduced, then I do bottoms up. I'm going to let you finish 3 on your own. I'd like you to go down to number 4. Okay, so what's different about this is that we now have a 4 instead of a 2. So same concept. What multiplies to equal positive 30 and combines to give you a negative 11? What multiplies to give you a positive 30 and combines to give you a negative 11? That would be -5 and -6. -5 and -6. So x minus, oops, sorry, my fault here. Z minus 5 and z minus 6. Now the leading coefficient is a 1. So doing bottoms up by putting a 1 underneath isn't going to do anything because dividing by 1 doesn't reduce it. So right now this is good, but what I need to consider is that I need to take this 4 and break it up evenly by putting a 2 here and a 2 here. And if you're thinking to yourself, why didn't we do that in problem 1 and 2? In fact, we did it. You may just not have realized it. We took this 2 and we broke it up into a 1 and a 1. Same thing here. We took the t squared and broke it into a 1 and a 1. So problem number 4 right now is in factored form. This is the factored form of this trinomial expression. Okay, we're going to go on right now to number 7. Please find number 7. So this is adding and subtract. This is the sum and difference of cubes. So b times b times b is b cubed, and 1 times 1 times 1 is 1. So I know there's going to be 2 things here and 3 things in back. I take one of the b's, I put it in here. I take one of the 1's and I put it right here. And now I cross them out. The symbol that was in the problem in between them goes in between. This back is always a positive. And when to determine this place, it's opposite of the first. Now I need to fill in these 2 places along with the last one. So how do I come up with these 3 terms? You have 2 b's left. B times b is b squared. 1 times 1 is 1. This middle term is achieved by multiplying these 2 terms. Don't worry about the positives or negatives. You've already done that. So b times 1 is 1b. This is the factored form of this expression. Hands raised if you'd like to try one more of those. Again, I was not here when you went over them. You were with Miss Nichols. Okay? So let's do this one. Now when you look at this, you're like, okay, well I can break s into s times s times s. The problem is I can't break 2 nicely into 3 parts. I can't go like 1 times 1 times 1 is 2, or 2 times 2 times 2 is 2. So what we're going to do is we're going to look at these two terms. Is there a number other than 1 that I can divide nicely out of 2 and 54? And you can. It is a 2. So let's divide a 2 out. Divide by 2, you end up with s cubed inside. Divide by 2, and you end up with 27. Okay, here we go again. Sum or difference of cubes. We can work with this one. This happens to be the sum. So s cubed is s times s times s. 27 breaks into 3 times 3 times 3. So I'm going to set this up. This will have 2 terms always. This will have 3 terms always. The last symbol in the second parentheses will always, for every single problem, be addition. The symbol in the first parentheses will be the same as you see in the original problem. And this final symbol, whether it's subtraction or addition, was always opposite of the first. Okay, I've taken care of the 2. The 2 is already here. We take one s down and one 3. In the first parentheses, s times s is s squared. And the last part of the parentheses, the last term in the second parentheses, 3 times 3 is a 9. Now, how do you get this parenthesis? To achieve this number, we look over here and we go 3 times s is 3s. Don't worry about the sign. We've already taken care of it. 3 times s is 3s. We are done. Okay, please flip to the back right now. Please flip to the back. Ladies, you're gone too often. You're coming in late too often, okay? I know you have a pass, but I need you here on time. Yeah. Okay, so let's do one more like it, okay? So what you have to ask yourself is, can you nicely break up 27? If you're like, I don't know if I can, here's how you figure it out. 1 times 1 times 1, is it 27? What about, do it in your head, 2 times 2 times 2, is it 27? What about 3 times 3 times 3? Okay, so let's write it down. 3 times 3 times 3. We have d times d times d. Now, can 64 be broken up? So, I've already done the 3's. What's 4 times 4? 16. What's 16 times 4? I'm waiting for you guys to tell me. What's 16 times 4? It is 64. What I did is I just made sure that I can nicely break up 27 into 3 equal parts being multiplied, d into 3 equal parts being multiplied, and 64 into 3 equal parts being multiplied. If you can't do that, then you can't factor this using this method. It's not factorable, okay? If we couldn't do that. So here we go. We have 2 terms in the first and 3 terms in the second. As a reminder, in the second parentheses, your last term is always positive. In the first parentheses, it is a subtraction, because we get that from the original, and whatever this is, opposite goes in the second parenthesis. Okay, I'm going to take out one of the 3's and one of the d's, so 3d, and one of the 4's. These came from the front, it remains in front. These came from the back, it remains in back. Now, in the first term, in the second parentheses, you have 2 3's left and 2 d's. 3 times 3 is 9, d times d is d squared. In the second parenthesis, at the last position, 4 times 4 is 16. How do you come up with this middle term? Forget about the sign. We've already taken care of it. We multiply these 2 terms. 4 times 3d is 12d. I'm going to let you do 11 and 12 for practice. Let's look down to number 13. Can you do me a favor? Is this coming back to you from what you learned before I came? Thumbs up, thumbs down. Okay. All right. So this is a review from Algebra 1-2 and also what you went over when I was gone on maternity leave. And so we're going to factor by grouping here. So I'm going to look at the first 2 terms. First 2 terms in this expression. What's the most I can pull out of those first 2 terms? And there's 3 m's here and 2 m's here, so the most you can pull out of both is 2 m's, m squared. Now I need to figure out what goes into this parenthesis so that when I take time and I distribute the m squared, I end up with this. So m squared times what gives you m to the third? You need one more m. And m squared times what gives you m squared? 1. Now we're going to do like copy and pasting just like a computer. Whatever is in parentheses, I'm going to copy it and paste it and put it in back. And really lightly, I'm going to put a question mark here. Really lightly. Now I need to figure out what number times m is m. What's the only number you can take times m and still end up with m? A 1. And is that same number times 1 equal to 1? Okay. So everything I've done so far is correct. Now I write down what's in parentheses one time. And then I go what's in front of the first parenthesis and what's in front of the second parenthesis. Problem done. I do want to let you know that whether you write the parentheses in a different order, these are both equivalent answers. They're both factored forms of the first expression. Hands raised if you'd like to see one more problem like this. Okay? Let's go on to number 14. Looking at the first two terms in this expression. What's the largest number? What's the largest number I can divide out of 12 and 20? A 4. And I cannot take an n out of both terms, but I can take a g. In fact, I can take a g squared out. Now I need to determine what goes inside the parentheses when I distribute. So 4 times 3 is 12. I need to end up with a 12ng squared. So here's 12. I need an n still, and I already have a g squared. If I distribute this, I end up with this term. Now I need to get positive 20g squared. So 4 times 5 is 20, and I need a g squared, and I already have it when I distribute. Take what is in parentheses, and we're going to copy and paste what's in parentheses in back. And put a really light question mark in front. What times 3n? What times 3n is a negative 3n? What number? So I'm going to really lightly put it here. Is negative 1 times positive 5 also negative 5? Yep, then I can keep going. Okay, so this is all correct. This is a negative 1. I take what's in parentheses, I write it down one time. Then it's in what's in the front of the first parenthesis and what's in front of the second parenthesis. This is the factored form of this expression. But in this case, we can go one step further. Hands raised if you see how we can go one step further. Okay, we have one person that sees it. I'm going to stop for a second and just do a quick mini lesson here. Quick mini lesson. If I said x squared minus 25, hopefully at this point in your math career, you know that's x plus 5 and x minus 5. How do we do that? We have to have a subtraction. 5 breaks into 5 times 5, x breaks into x times x. Let's do one more. If I said 9x squared minus 64, because these two numbers are both perfect squares, and you have a subtraction, 9 breaks into 3 and 3, stays in front. 64 breaks into 8 and 8, stays in back. Because we have subtraction, we can do it. One is positive and one is negative. Does not matter which one is positive or which one's negative. And x squared breaks into x and x. Hands raised if you understand those. Okay, so here's how we can take this and we go one step further to have the correct answer. We keep 3n plus 5. That's correct. But do you see how 4 and 1 are both perfect squares? 4 breaks into 2 and 2, stays in front. 1 breaks into 1 and 1. And we can only do this when we have subtraction. We have one positive and one negative. And g breaks into g and g. This is your final factored form. You do have to take it one step further. In the past, I've had students ask, what if it's addition? Then you can't take it a step further. Other students have said, what if one is like 4 and the other 7? Well, they're not perfect squares. Then you would not be able to take it one step further. All right. I'd like you to flip over. Find number 1. write an equation in factored form, and then solve to identify all the solutions. Okay, so what we are finding is we are finding where are the x-intercepts, where are the x-intercepts for our real solutions, and we may have some complex solutions with i's as well. We may have some complex solutions with i's. So how do we do that? Well, we're first going to factor. So does 16 break into two equal numbers? What times what equals 16? 4 and 4. So right now we're just going to put it in factored form. So 4 and 4 stays in front, and 1 breaks into 1 times 1. Because it is subtraction, I can do this. 1's positive and 1's negative. Now when you take x to the fourth and you break it up into two equal parts, what does each part become? X squared. So it says write it in factored form. This is factored form. This is an equivalent form of this equation. And then it tells you to identify all of the solutions by solving. So let's start with this one. By the way, can you put a little arrow to the x to the fourth? We should have 4 answers. So I'm going to start with the first parenthesis, and I'm setting it equal to 0. Does anybody know why we set it equal to 0? We're trying to find x-intercepts, right? Yes? Okay, I want you to think of x-intercepts. Think of one in your head, and I want your partner to think of one. Okay? Doesn't matter what answer it is. Think of an x-intercept. Now turn to your partner, and I want you to tell your partner what would be the ordered pair of your x-intercept. And then vice versa, I want your partner to tell you what would be the ordered pair of their x-intercept. 5 seconds, go. What did you and your partner have in common in your answers? The y was 0. Do you guys agree the y was 0? Look at this. This was a y. Now what does it become? We're trying to figure out when would it be 0. When would it be 0? When would the y? So here we go. First step, let's subtract 1 to the opposite side. Second step, to isolate the x squared, divide both by 4. Third step, we want to eliminate the square. Opposite of squaring something is to take the square root. Notice that this also tells you you're going to have 2 answers. How do you get 2 answers? Plus or minus. Now, can you take the square root of a negative? So that negative comes out front and turns into an I. The square root of 1 is 1, and the square root of 4 is 2. And I put the I in back of the number because technically, that's the proper way to write it. If you put plus or minus I 1/2, it's not wrong. It's just not written in proper form. So again, how many answers from this original problem did it say we were going to have? 4. And how do we find that 4? It's the highest exponent. So here's 2 answers. One answer is plus or minus 1, one answer is plus 1/2 I, the second answer is minus 1/2 I. And I just don't want there to be a confusion, so I'm going to switch colors. You don't have to. And now I'm going to take the second parenthesis, and I'm going to do the same thing. I'm going to set it equal to 0. Add 1 to the opposite side. Divide by 4. To eliminate the square, take the square root. How many answers should I have? 2 answers. To get 2 answers, to achieve them, I put a plus or minus. The square root of 1 is 1. The square root of 4 is 2. Can you turn to your partner and in 10 seconds tell your partner why did this result in no i's, but this problem had an I in it? So your partner, go. 10 seconds. Okay, let's go on to number 2. So first they want us to write it in factored form. In factored form is our first goal. So we have 12 times negative 6. What is 12 times negative 6? I believe it's negative 72. So we write down negative 72. I want to come up with 2 numbers that multiply to give you negative 72 and combine to give you a positive 1. As a reminder, I will teach using bottoms up method, but if you happen to use the X method from Ms. Castro, or you have a box method that works, feel free to use a method that works for you. So I believe that positive 9 and negative 8 multiply to equal negative 72, and they combine to give you a positive 1. So x plus 9 and x minus 8. On your previous test, you were given a problem similar to this, and you were asked to write it in factored form. And a lot of you stopped, if this was the problem, you stopped right here. But what am I forgetting to do? Divide by, if the leading coefficient is different than 1, we have to divide. So divide by 12 and divide by 12. So I can reduce this fraction. Both are divisible by 3. Divide by 3 and divide by 3. Both are divisible by 4. Divide by 4 and divide by 4. And bottoms up now, it's been reduced as far as possible. 4 pushes up and 3 pushes up. 4x plus 3 and 3x minus 2. This is factored form. Factored form is y equals, okay, it's not just this, it's y equals. It's an equation that's equivalent to this standard form. Now, to actually solve, I'm going to take each parenthesis and I'm going to set it equal to 0. Look back to the original problem. The degree of this problem, which refers to the highest exponent on a variable, is a 2. So that tells you how many answers should you have? You should have 2 answers. Subtract 3. Divide by 4, and here's 1 answer. Add 2. Divide by 3, and there's your second answer. Thumbs up or thumbs down at this point? Thumbs up, thumbs down? Let's try one more. Actually, let's do 2 more. I'd like to do number 3. What is the largest number that's divisible by 40 and 5? What's the largest number you can divide into 40, and you can also divide it into 5 nicely? 5. What's the maximum number of x's I can take out of both terms? 1x. 5 times 8 is 40. I need a total of 4 x's. I only have 1. I need to put 3 more down. 5 times negative 1 is negative 5. I need 1x, and I already have it. This is not factored form yet. So, about 10 minutes ago, we reviewed the sum and difference of cubes. Let's break this apart. 2, 2, 2, x, 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 1, 1, 1. So, this is the form you will use whenever you are working with the sum or difference of cubes. In the second parenthesis, the last term will always be addition. The sign in the first parenthesis will always come from up above here, and it will be always opposite in the remaining position. So I'm going to grab 1, 2, and 1x to multiply and put it in front, and 1, 1 to put it in back. Two times 2 is 4. X times x is x squared. So I have 4x squared goes in front. And 1 times 1 is 1. It goes in back. Forgetting about the signs, if you multiply these two, 2x times 1 is 2x, and it goes in the missing position. This is factored form. This is factored form. It has to be y equals. This is factored form. Now, when we actually get our answers, how many answers should we have? We should have 4. So the first 2 are really easy to get. Some of you can even do it in your head. So I'm going to set this first portion, and I'm going to write really small, equal to 0. Divide by 5. 0 divided by any number is 0. There's 1 answer. Then I'll come to the second factor. I set it equal to 0. Add 1 to both sides. divide by 2, and x equals 1/2. And again, I'm not sure, how in depth you went with Miss Nichols with this, because this is all previously taught this year. But this, if she did not tell you, this trinomial with the sum or difference of cubes, the trinomial every single time will not be factorable. You always, always have to use the quadratic equation to solve for this. So right now, please work ahead of me. You can look up at the screen to check your work with mine. Please use quadratic formula. If you're blanking, what am I talking about? It's x equals negative b plus or minus squared, b squared minus 4ac all over 2a. Okay, use that to solve this trinomial, this factor. Quick raise of hands. Would anybody like me to vocalize how I got this as a final answer? So I started with looking up here. My A is 4, my B is 2, and my C is 1. I plugged in against negative B, plus or minus the square root of B squared minus 4AC all over 2A. So I inserted 4, 2, and 1 for A, B, and C respectively. Then I did the math. 4 times 1 is 16, brought down the subtraction sign, 2 squared is 4. And I subtracted to get a negative 12 inside. But you can't take the square root of a negative. So I took out the negative, it becomes an I. Now 12 can be broken down because the square root of 4, which is a perfect square, nicely divides into 12. This breaks down to 4 times 3. And the square root of 4 is 2. So this is 2i squared to 3. Now this 8, to simplify this, needs to be able to be shared with both negative 2 and positive 2. So I share it with both, and then I reduce the fractions. Thumbs up and thumbs down if you're able to understand how I was able to simplify that. Okay, come see me tomorrow morning if you need a little help with that. I have no problem helping you with that. Let's look at number 5. Okay, look at the first two terms. What can you pull out of the first two terms? Let's talk first just about a number. What's the largest number that can be pulled out of 2 and 6? 2. And what's the maximum number of x's I can take out? There's 4 here, 3 here. Maximum is 3. 2 times 1 is 2. I need 4 x's. I need 1 more. 2 times 3 is 6. I need 3 x's, and I already have those. Okay, I'm going to copy and paste just what we reviewed earlier today. I'm going to copy and paste this 1x plus 3 in back. I'm going to put a really light question mark in front of it. So ask yourself, what times 1x, make sure I wrote this down here, what times 1x equals 18x squared? Oh, you know what I forgot to do? I am so sorry. We're going to stop here. Good learning lesson. I just jumped into this full force. Let's first look and see what we can do. This will make life even easier. Do you see how each one of these numbers is an even number? Does everybody see that? So let's just put a 2 out front to start with. And do you see how all 4 of the terms has at least a minimum of 1x? So I can divide each one of these terms by 2 and by x. How do you divide by 2x? 2 divided by 2 is a 1. I need to achieve 4 x's. I only have 1. Attach 3 more. 6 divided by 2 is 3. I need 3 x's. I only have 1. Attach 2 more. 18 divided by 2 is 9. I need 2 x's. I only have 1. Attach 1 more. And 54 divided by 2 is 27. I need 1x, and I already have it. Okay, leave this factor out front alone. Let's focus on this. In this region, let's look right now at the first 2 terms. So other than 1, there's no number I can divide by both of these nicely. But I can take out 2 x's out of both terms. So let's take 2 x's out. X squared times x is x cubed. And x squared times 3 is 3x squared. Whatever was in parentheses here, I'm going to copy and paste it in back and put a really light question mark in front. What number times x gives you 9x? A positive 9, and is positive 9 times positive 3 positive 27? Yes. So I take what was in parentheses for this portion, and I write it down, and then what went in front of the first, and what went in front of the second. And then bring down that original factor that we pulled out. Now, many of you may be thinking, can I break this into x plus 3 and x minus 3? Turn to your partner in 10 seconds. Yes or no, and what's your reason? Can you break this into x plus 3 and x minus 3? Okay, the answer is no. There's one reason, only one reason. What is it? It's positive, needs to be negative. That means this is the factored form of the expression up above. Now, how do you solve it? Well, let's look up above. How many answers do we want? 4 answers. So how do we solve it? Let's take 2x equals 0, divide by 2, and x equals 0. X plus 3 equals 0, subtract 3, x equals negative 3. And then x squared plus 9 equals 0. Cannot take the square root of a negative, so it comes out front and becomes an I. And the square root of 9 is 3. What do these answers mean to you? It means if we took this original problem in standard form or in factored form, they're the same problem in different forms, and we plugged them into the graphing calculator and we graphed it, we would see an x-intercept at 0 and at negative 3. Those are the visual ones we can see. On a graph, we cannot see where the actual complex solutions come, but we do have 4 solutions, 1, 2, 3, and 4.